I wanted to give a really quick clarification of how to tell if a line has a positive slope or negative slope, because I don't think it was totally clear in the Khan Academy video, or emphasized really enough. Just a really quick way to recognize it. We've seen a lot of lines that look like this. Lines that some students have described this as uphill, which is not a bad description. Lines that kind of have that uphill, think of if you're going from left to right, that you'd have to climb up, those are positive sloping lines. And it doesn't matter where they're at in the coordinate plane. They can be in this negative region. Some students were just kind of looking at where they were in the coordinate graph. They can totally be in that negative region and still have a positive slope. It all has to do with that uphill idea. It's a growing relationship. As the x values get larger, the y values are also getting larger, creating that upward sloping line. Now, visually, a negative sloping line is always going to go in this direction. And it doesn't matter where it's at on the graph. It could be up here, it could be down here, it could be over here, but ultimately the idea is that it is going in this somewhat downhill, kind of downhill or downward direction. Think of if you were starting on the left going right, you would just be cruising down that hill. So generally this downhill direction is what signifies a negative slope. And what's essentially happening there is as the x values get larger to the right, the y values are getting smaller. It is a decreasing, it's a decreasing relationship. It's not growing, it's decreasing, and that's represented by that downhill view. You still always want to consider your vertical change over your horizontal change, so that your ratio always has the same format. But generally one of those values, when you have that downward sloping, one of those values is negative, and I'll explain that in the next screen. So Sal tried to explain this. He did an okay job, but just to really help clarify, just like when you're reading a book, just like when we are reading expressions and doing our order of operations, we always move in a direction of left to right. And when you're looking at slope, the idea is the same. So if I'm starting at a point down here, when I count the vertical change, if I were to try and count the slope between these 2 points, well, I'm going up, which is a positive thing, right? Up is generally positive, down is negative. Up is positive. And then if I have to go to the right to meet me at my other point, that's also in a positive direction, right? I'm going in the direction of positive values. So the change in y is positive, and the change in x is also positive, which is eventually just overall going to give you that positive slope. Now with a downward sloping line, if I have a point here and a point here, once again, I want to move from left to right. I want to start with the leftmost point and make my way to the rightmost point. And so if I start at the point on the left, which is higher, in order to get to that other point, I'm going to have to go down. And if I go down, that's a negative direction. However, I am going to the right I'm going to the right horizontally. My horizontal change is positive, but my vertical change is negative. So my change in y is negative, my change in x is positive. So ultimately, your ratio, it's kind of like a division idea. So if one of those values is negative, then overall my slope is going to be negative. And you might be asking, well, but what if I start at this point, but what if I go horizontal first? Does it still work out the same? Well, yeah, I could take this path. I could go horizontally first, which is still in the positive direction, but I will still end up, when I look at that vertical change, that's still going to be in a negative direction. So my horizontal change is still positive, my vertical change is still negative, no matter which pathway you take, and ultimately that gives you a negative slope.